Hi guys and welcome to Programming in Objective-C. I'm Yari Dareglia of Jump Zero, and in this course I'm gonna walk you through the language fundamentals as well as some more advanced topics. Whether you want to master development for iOS or OS X, or if you just want to learn a new language, this course will be a good starting point. So, let's start with the first lesson. Today we're gonna be talking about what Objective-C is, with a simple introduction about the word of this language. Then we'll be moving on to coding, and we'll obviously compile the first hello world in Xcode. And finally, we'll talk about data type and format specifiers. Objective-C was designed to add object-oriented capabilities to the C language, with a set of extensions mostly based on Smalltalk. It's a compiled language. Your source code passes through a compile procedure to be transformed into a program that can be executed. The compile procedure is a set of linked steps. Each of them has its own different goals. Objective-C became popular thanks to Next Steps, an operating system developed by Next, which implemented a framework called Foundation. In that framework we have many implementations such as wrapper classes and data structures that we are going to analyze in future lessons, together with dynamic typing, blocks, introspection, and object messaging, other features that make this language awesome for coding. All this said, let's move to our project. Before we start, you need to have Xcode installed on your system. If not, pause the video and take your time to download it from the App Store. It's gonna take a while. When you're done, open Xcode. In the first window, click on Create a new project. You should see a list of available templates. And from macOS section, choose Application, and on the right side, Command Line Tool. You will notice that we are creating an application for OS X. Fear not, everything applies exactly the same way to iOS. In this window, we set the project name. Let's call it Introduction. The bundle identifier is a unique ID to define your application in the operating system, in iOS as well as OS X. Then you can define the type of your project. Choosing Foundation is the right choice if you want to include the needed framework, but you could also create C or C++ application. Remember to check Use Automatic Reference Counting. We'll cover ARC in the next lessons. Suffice to say this will ensure a huge help in memory management. Choose a project folder and take a look at this option. We can create a local Git repository directly managed by Xcode. Check it. Now, I want to spend a few words about the Xcode interface, to be sure you feel comfortable with it during these lessons. Xcode is mainly organized in 3 columns. The left bar contains the navigator area, where you can browse project files, perform searches, get information about warnings or console lag history. We can't forget about the utility column on the right for the moment, as we won't need it for this course. The middle area is dedicated to file contents. This is the main editor window and it has 3 different views triggered by these buttons. The standard editor, the assistant editor, which has a split pane view that automatically presents a file related to the current file, and the source control editor, to compare file with versions stored in the repository. In the center column, at the bottom, there's a console where log messages will be shown. Now we are ready to look at some code. So select main.m file in the project navigator. .m is the extension for the implementation files in Objective-C, and the main.m file is the starting point for every application you are going to create. As you can see, main.m first imports the foundation framework. Then defines the main function. This is going to be the first function called by your application. The @autorelease pool is connected to the memory management, but for now we don't need to know more than that. Let's move to the nslog function. This function generates console messages, and it takes a string or a formatted string as parameters. Look at the sign before the string. This is an Objective-C directive to define a UTF-8 string. Don't worry, we'll see something more about this definition soon. The return 0 identifies the end of the program. We can now compile this simple project. Just click on the Run button in the top left corner, and the code will be compiled and executed. You can now check the nslog output in the console and be proud. The first step is done. I'm sure you'd like to move on to something more challenging, so let's start by introducing data types. In this table, you can see numeric data type inherited from C. The int keyword stands for integer number. The float is for single precision floating point number, and the double, with its bigger dimension, is used for a more precise numeric definition. For example, to use more than 7 numbers after the point. Two other values directly inherited from C are boolean and characters. A boolean has only two possible values, 0 or 1, true or false, and specifically in Objective-C, yes or no. A character is used to define a Unicode value, so you can fill a variable either with a numeric Unicode value or with literal characters. Now, I want to show you a fast calculation to know the exact capacity of a specific data type. Take as example the integer, that uses 4 bytes to store its information. 4 bytes are equal to 32 bits, and 32 bits are equal to 2 to the 32nd, that results in more than 4 billion possible values. If we also need negative values, we have to consider a range from -2 billion to +2 billion. But in case we only need positive values, we can increase this range by using the keyword unsigned, shifting the range from 0 to more than 4 billion. Remember that neither float nor double numbers can use the unsigned keyword, because they have 1 bit dedicated to the sign. Take a look at their data structure. You see the sign bit, the exponent bit, and the fraction bit. So you have to define the sign. Here you can see how the long and short modifiers can change the size and consequently the capacity of a data type. For example, a short int can only use 2 bytes, while a long double goes up to 16 bytes. Now, let's define some variables using the data types you just learned. Let's say I want to create an integer. I can write int I equal 100. In this case, if I want to print my integer through the nslog function, I can write nslog at my int, for example, %d I. The %d is a placeholder for a variable of type int, in this case for I, that is equal to 100. If I try to compile this code, I get my int 100. Let's say I want to add another number, for example a float. So I write float f equal to 1.1. In this case, if I want to add my float number to the string my int %d, I can write %f, and after the I write f. The first value in the string, the first specifier, will be substituted with the first value after the string, and the second value, %f, will be substituted with the second attribute after the string. So I with the %d and f with %f. If I try to compile, I get this strange format. 100, okay, and 1.10000. We don't need it. So we can say 0.2f. Take a look. And in this case, I get only 2 values after the point. Okay, so I can define 3 and so on. Okay, now move on with the last example. Let's say I want to create a boolean. You remember that a boolean is only 0 or 1, true or false, but in Objective-C we use yes or no. And if I want to print this value in the nslog function, I can say %d. So I use the same specifier that I use for the integer. And here I write b. If I try to compile, I get 100, 1.1, so on, and 0, my boolean. You can find a list of every specifiers on the Apple documentation, searching for string format. That's it for now. Take your time to review these first elements about Objective-C and experiment with these basic files we've just created. In the next lesson, we are going to start using what we learned in something a bit more challenging. See you soon and thanks for watching!